Smart cities are the new buzzword. This market is exploding. The market size of smart cities is already at $410 billion now in 2020, and over the next 5 years, this market is projected to be worth around $820 billion with a CAGR of around 14.8%. So, one of the consequences of this exploding smart city market is the explosion of cameras. You are going to see cameras everywhere. Embedded vision is going to become ubiquitous. So then, as an engineer who's working to develop these smart city applications, you might have a question. How do I choose the right image sensor or an embedded camera for any of my smart city applications, right? But then over here, we have a myriad set of applications for smart cities, such as parking lot management or surveillance, intruder detection, business situation monitoring, etc. For all this, you need to choose the right cameras. Hi, this is Alphonse, and in today's edition of Unraveling Computer Vision and Edge AI for the Real World, we will be exploring a little bit on how to choose the right image sensor and embedded camera for your smart city application. Based on my team's experience in building more than 15 plus embedded solutions and creating cameras for this vertical, we have understood the first and foremost challenge we face while building smart city applications is the variation in lighting. For example, almost all smart city applications such as traffic management or your parking lot management, your cameras will be placed in an outdoor environment, which means your camera should be able to capture within a single scene the brightest objects placed under the sun and the sky, while also the darkest regions such as the shadows under the tree are also captured properly. The only way to choose the right camera for this kind of scene is to make sure these cameras have a very wide range to capture both the brightest and the darkest images accurately within a single scene. My team here at Visai Labs uses the C3 Cam CU20 to solve this problem. Another subset of lighting problems which you will face while building AI and CV based applications for smart cities is the problem of managing both day and night lighting. For applications such as intruder detection and surveillance, you need a camera which can run 24/7. And these cameras should be able to capture detailed, accurate images both in day and nighttime. In order to have such cameras, you need to have a specially designed image sensor which has NIR lighting capability. NIR lighting can help cameras manage the deficit of visible light. We see that there are many specifically designed image sensors which are highly sensitive to the NIR spectrum. To solve this particular problem, we at the Visai Labs actually use the Hyperion image sensor. Now, with the problem of lighting out of the way, we now enter into the third problem which most people will face while building smart city application. That is the problem of accurate details. In this scenario of accurate details, we are very prone to fall into the bias of the cheerleader effect in imaging. Well, whilst the overall image might look perfect, once you zoom in and you look at the specifics of the image, you will notice that the individual effects are very grainy. But you want the entire image along with the internal parts to have high degree of accuracy. Otherwise, your algorithms will not be able to process the image and give you a perfect output. Truth be said, cameras which do surveillance and monitoring rely on providing images which have low noise output. The machine learning algorithms also depend on neutral color reproduction, irrespective of the lighting conditions, be it artificial or natural, to do the right processing and provide you with the right output. The challenges in lighting also poses and significant problem in the sense that it might induce noise into the final output, and this is very undesirable for most algorithms. So one of the ways we actually solve this problem is by identifying cameras which have large pixel sizes, as they typically have better SNR and they have the ability to reproduce true colors. The camera which my team at Visaya Labs uses is the C3 Cam CU20, especially when we are building these outdoor focus use cases for smart cities. That being said, there are an n number of applications for smart cities, and if and when implemented right, have the ability to be useful to a large swathe of humanity. But according to VentureBeat, more than 87% of AI projects do not go live into the production stage. The major problem here is because we do not choose the right set of hardware and edge-based ML algorithms right in the POC stage. So the transference from POC to a production-ready AI application is actually very low, and we, the team at Visay Labs, hope to increase it. But then, hey, that's other topic for another day. Today, however, hopefully you have learned something about what kind of image sensors can be used for smart city applications, and you would find some of the suggestions on what image sensors to use to be very useful. This is Alphonse signing off, and hopefully, I would connect with you in another session of unraveling edge AI and computer vision for the real world. Ciao.